Hello students, in previous lecture series video related to BCNF, we converted unnormalized form into 1NF, 1NF to 2NF and 2NF to 3NF. Up to 3NF we have seen. So in 3NF we have three tables: property inspect, property stack. These are the three tables in third normal form. Now we are seeing and now we are converting this third normal form tables into BCNF, which is more stronger than third normal form. What is the definition of a BCNF? All determinants, that means every determinant in a table must be candidate key. What is candidate key? Candidate key is the minimal number of attributes, set of attributes which identify each row in a table uniquely. Every table can be known by a candidate key. So that is what we are going to check. So for this, to test for BCNF, we simply identify all the determinants, means all the left hand side attributes in the functional dependencies in these three tables. All the determinants and make sure they are candidate key. Just we are checking all these left hand side attributes of a functional dependencies and make sure they are candidate key. So we can see that the property and staff, these tables, property and staff relations, are already in BCNF because the determinants in each of these tables, in each of these relations, is also candidate key. If we know property number, we can know P address. That means, so by that every tuple in that table can be identified by knowing this property number. Same like in staff table also. So only single determinant we have and single dependent. So already these tables are in BCNF also. Now we have to check with this property inspect and we have to check all these functional dependencies related to property inspect table. So here you can identify this FD4. In if you take FD4, functional dependency 4, the staff number comma IDate is not a candidate key. Why it is not candidate key, I'll tell. So let us see with the example. So staff number IDate, which is not a candidate key. So you can observe here in FD4. So property inspect relation may suffer from update anomalies, that is update problems, because of having this. That means left hand side attribute is not a candidate key. So it may suffer from problems. So to remove that problem solve, we need to convert this into BCNF. That means make sure all the determinants are candidate keys. So in FD4 we identified the staff number IDate is not a candidate key. Why it is not candidate key? Let us see. For example, to change the car allocated to staff number SG14. So I want to change the car allocated to SG14 on the April 22nd. See, with the April 22nd date, we have two rows, two tuples for staff number SG4. I want to change the car of this staff number on April 22nd. So how many rows we need to update? 2 rows. So if only one tuple is updated, what happens? If only one tuple is updated with a new car registration, that means whatever the change I want to make, that is only done with one tuple, what happens? Definitely it leads to inconsistency, incorrectness. That means I made a change in the second row on April 22nd, SG14, and new car registration, new car details I added, but I have not done that same change in fourth row. What happens? Definitely it is incorrect. If I change a car on the April 22nd in the second row, definitely I need to change in the fourth row also, because same date, same staff number, and here also I have to change with a new car. If it is not done, definitely it leads to a inconsistency, incorrectness. Here staff assigned same car for the whole day, and staff could inspect more than one properties on the same day. That is, if we know staff number and inspection date, we could only identify one car. But what is candidate key? What candidate key means? It could identify every row, that is every property details in the table. But that is not happening in this FD4. So, staff number IDate is not a candidate key. So, to transform the property inspect table into BCNF, we must remove the dependency that violates BCNF by creating two new tables, two new relations called staff car inspection. Staff car and inspection is the two new table names we kept. So what are the attributes we have? So staff car is the table which contains staff number, IDate, car registration. That means wherever we identified in which FD we identified that a determinant is not a candidate key, we separated all these three attributes as a separate table and we named as a staff car. So this is the table name which we kept. Staff car is a table with these attributes, and this is inspection table. Inspection table contains property number. See here. Property number, IDate, ITime, commence, staff number. Property number, IDate, ITime, commence, staff number. These are the attributes we are having in this inspection table. So, two tables we have created. Now, these two tables are in BCNF as the determinant in each of these relations is also a candidate key. In summary, the decomposition of staff property inspection relation, the original table, into BCNF relations is shown in this figure. The original relation is staff property inspection table. So this staff property inspection table we converted into 1NF first, then 2NF, then 3NF, and finally into BCNF we converted. So how many tables we have in BCNF? Inspection, property, staff, staff car registration. So these are the four tables we got finally from the original relation after removing all the dependencies. So always you have to remember the one more point, that the original relation staff property inspection can be recreated from the property inspection staff and staff car relation. That means all these tables, all these 4 tables, if we combine, the original relation should be recreated. That is called as lossless joint dependency. That means when we combine all these small tables, the original data should be recreated without any loss of data. Without any loss of data, that original data should be created. So this is one important property we have to remember, that any larger table is decomposed into smaller tables in the process of normalization. That is, again, if we try to reconstruct all the small relations, the original table should form without loss of any attributes or data. Okay, so this is all about normal forms.